Hello everyone, my name is Lawrence Akintokun. I'm here to present a lesson plan to ITEC course 7430 at Kennesaw State University. The title of my lesson plan is Percent Composition, Empirical Formulas, and Molecular Formulas. Now let's get started. Let's look at the standard I'm going to address. Georgia Standard of Excellence I'm going to look at is SC3C. Obtain, evaluate, and communicate information about how the law of conservation of matter is used to determine chemical composition in compounds and chemical reactions. Use mathematics and computational thinking to apply concept of the mole and Avogadro's number to conceptualize and calculate percent composition, empirical, molecular formula. Our learning target is I can determine the percent composition of compounds and find the empirical and molecular formulas. Student assessment will be ability to calculate the percent composition of compounds, determine the empirical and molecular formula. The ITSC standard I'm going to look at is ISTS2, Research and Information. Fluency students apply digital tools to gather, evaluate, and use information. Students will be able to 1. Plan strategies to guide inquiry, locate, organize, analyze, evaluate, synthesize, and ethnically use information from a variety of sources and media. C. Evaluate and select information sources and digital tools based on the appropriateness to specific tasks. D. Process data and report results. And the target for that is that I can use technology to listen, watch, and solve problems in chemistry. I can collaborate with my peers in class to solve problems on whiteboard and share with my fellow students in the class. Now I develop a concept map which is going to explain all the content area, how they are interconnected. Now if you look at percent composition as the main focus at the middle, it's linked to empirical formula. So that means from percentage composition you can get to empirical formula. Empirical formula leads to molecular formula. Now the molecular formula is empirical formula times N. Now how do you get your N? Your N is the molecular formula mass divided by the empirical formula mass. Alright, percent composition can also be calculated in this form as mass over total mass times 100%. And we can get our mass by looking at the molar mass of all the compounds. That is total mass. To get the total mass, we can look at the mass of individual elements in that compound. To get our atomic mass or the mass of the substance, we look at the atomic mass on the periodic table. Now this is our periodic table. It has all the elements that we're looking at. This number at the bottom is your atomic mass for titanium. Vanadium has 51. The number at the top is just the atomic number. If you look to the left, you see sodium is 23 grams. 11 is atomic number. Potassium has 39. That's the number at the bottom. The atomic number is 19. Calcium has 40. And the atomic number is 20. So, this percent composition video has been sent home to the students through their Google Classroom in form of flipped classroom. We have 2 videos sent already, one made with Edpuzzle, the other one with Spark Video. So they watch the video before they come to class. Now let's go to the main concept. Percent composition, as the definition says, is the mass of each element in a compound. So this is the parts of the elements of the compound over the whole times 100%. So, in other words, percent composition of a compound or molecule is the mass of element in 1 mole over the mass of 1 mole. So the difference is that element is just part of the whole substance, the whole compound. We shall see more example in the next PowerPoint. So the mass of the whole, but 1 mole is just the mass of the whole compound, instead of just part, which is just part of the element that made up the compound. Let's take an example. What is the percent composition of potassium permanganate? The formula for potassium permanganate is KMnO4. Now, emphasis should be placed on this 4. That 4 is what we call the subscripts. Now, the subscript is a number that multiplies only the element that is written with. So let's look at this. Molar mass of potassium permanganate. We look for molar mass of potassium, which is 39.1. Because you have only one potassium, that is that one. You multiply 1 by 39.1, you get 39.1. Molar mass of, atomic mass of manganese is 54.9. And it has only 1. If you don't have any number written there, it means it's just 1. It's an imaginary 1. And then the next one is oxygen. The atomic mass of oxygen is 16, multiplied by 4, which is the subscript. So you multiply 16 by 4 will give us 64. So the total mass is going to be 158. So this is the total mass for the potassium permanganate. Now we want to look at the percentage composition of each of the elements. Now we start with potassium. Potassium is K, which is 39.1 over the total, 158 grams times 100. That will give us 24.7. All right. The next one is manganese. Manganese is 54.94 divided by 158, the total mass of the compound, times 100, give us 34.8. The next one is oxygen, which is 64. Now, emphasis must be placed here. Most mistake are made by students is that they use 16 instead of 64. Most of them forget to multiply with the subscript. So we have 64 over 158 times 100 will give us 40.5. Now it's just a fact check. If you add up all these numbers, you will get 100%. All right, teacher will now give them this practice example. Ask them to work in group. Now you will go through this one by one. Sodium carbonate. Sodium is Na. It has 2 subscripts multiplied by 23 from the periodic table, which gives us 46. Carbon is 12. Carbon is 12. Is only 1 carbon, so 1 times 12.01 will give us 12. Oxygen is 16, but we have 3 of oxygen. That will be 3 times 16, 48. Total will be 106. So, do not take them one by one. 46 over 106 divided by, times 100 will give us 43.4. Calcium is 12 over 106 times 100 will give us 11.3. Oxygen will be 48 over 106 times 100 will give us 45.3. Now, the teacher will now pause and give them this problem to solve. After a couple of minutes, teacher goes around to see how they are solving the problems. The student work in group with whiteboard, with dry erase, so they can easily make corrections when they make mistakes. After teacher has gone around, then we'll show them the answer. They compare the answer with what they have. And then we'll give them another example, ask them to solve this as well. And then after a couple of minutes going around, we check and give them the answer. Now, this is the gathered problem. Now, left with individual. This is the question for them to now do an independent practice. Now, after that, we'll now go to a mini lab. This probably will be the second day. Mini lab will be like giving them a pair up individual, a student with another person, then give them a brand of bubblegum. And ask them to design an experiment for them to find the percentage of sugar in the bubblegum they have. So, they will have to design the experiment themselves and find out how they are going to do it, and then give the teacher the feedback, the proposal, like the outline, what they're going to do. They will give an electronic scale, they have weighing paper, they have brand of bubblegum individually. Then they will ask to make a recommendation after the experiment to know the percentage of sugar that is safe for their teeth. Of course, we can decide to say, okay, if your sugar is more than 25% sugar content, then the bubblegum is not good for your teeth. Now we go to the formula aspect, which we're going to use the percent composition. We have two types of formula. Empirical formula, which is a formula of compound that expresses the lowest whole number ratio of atoms, while the molecular formula gives the actual formula of a compound, showing the number of atoms present. So the teacher now give them from the definition, we ask them what formula is C4H10. The expected answer is molecular formula. Why? Because this can be reduced to the lowest term. If you look at the empirical formula, it says formula of a compound that expresses lowest whole number ratio. But 4 and 10 can still be reduced to the lowest term of 2 and 5. So we ask the student to give the empirical formula, which means they're going to give us C2H5. Another example is C6H12O6. Of course, student will have to say this is molecular formula as well. And then teacher will ask them to give the empirical formula, which means they reduce the numbers to the lowest term. That will give us CH2O. So that leads us to this example, just fact check. Is H2O2 an empirical or molecular formula? The answer should be molecular formula because it can be reduced to HO. So HO is your empirical formula. Now calculating the empirical formula. Teacher gives this problem and then solve it with the students. Now you are given 4.550 grams sample of cobalt, which reacts with 5.475 grams of chlorine to form a binary compound. Determine the empirical formula for this compound. Now what you are given, the first problem here is to look at the percentage. 4.550, make a T-chart, 1 mole at the top. 58.93 is the atomic mass of cobalt on the periodic table. So they get this value. They look at the second one as well, 5.475 grams of chlorine. They now look at the atomic mass of chlorine, 35.45, and then they get the mole, which is 0.154. Now, the students are now asked to look at which of these two is the smallest number. And this, of course, 0.7721. Then they are going to divide each of these two answers with the smallest number to get the coefficient, to get the subscript. So this is the smallest number divided by itself will give us 1. This number divided by 0.0772 will give us 2. So the subscript for cobalt will be 1. For chlorine will be 2. So the empirical formula for that is COCl2. Right, we'll move on to another example. Teacher now lead them to solve this while it goes down to check. And then at the end of it, you give them the answers as this. Now, still going back to the concept mapping, we want to see how we connect the empirical formula with molecular formula. So to do that, we look for N. N is your molecular formula mass over empirical formula mass. So we use this formula to solve for N. All right. So having done that, we now give an example. A white powder is analyzed to have an empirical formula of this. The compound has a molar mass of this. What is the compound's molecular formula? So the teacher will now look at this and divide the molecular formula mass by the empirical formula mass to get your 2. So that 2 will now be multiplied by the empirical formula, which is this, P2O5 from the question. So when you distribute that 2, you now 2 times 2 is 4, 5 times 2 is 10. This is your empirical, this is the molecular formula. And teacher gives this problem for the student to solve. And the content assessment will be this. The student will have to solve this problem as the evaluation assessment. At the end of it, for this lesson plan, I've used Edpuzzle, Popplet, Flip Classroom, Spark Video, PowerPoint, and technology tools are periodic table and calculator. Thank you.